Number 31, use the intermediate value theorem for polynomials to show that the polynomial function has a real zero between the numbers given, and we have f of x equals 4x cubed plus 7x plus 4, and the numbers -1 and 0. And all the intermediate value theorem states, and this comes right from your textbook, page 326, is that if f of x is a polynomial function with only real coefficients, all right, so here's f of x. This is our polynomial. We have only real coefficients, right? 4 is real, 7 is real, our constant is real. And if for real numbers a and b, so we'll let -1 be a, we'll let 0 be b. So if for real numbers a and b, the values f of a and f of b are opposite in sign, then there exists at least one real zero between a and b. So with 31, all we're doing is we're going to use, well, really we can do one of two things here. We can either use synthetic division here using our -1 and the function, see what our remainder is. Is it positive or negative? And then we can use synthetic division again with 0 and our polynomial here. Again, see what the remainder is it positive or negative? And if the remainder, when we do, or rather when we use -1 and 0, are opposite, if one is positive, one is negative, then what that tells us is that there is some real number that exists between -1 and 0 for which if we were to perform synthetic division, we would end up with a 0 remainder, meaning that number between -1 and 0 is a 0 of this polynomial. So let's go ahead and perform synthetic division first with -1. And we know how synthetic division goes by now. We have to make sure we're in descending order and that we're not missing any terms. In this case, we go from 3 to 1 to none. So we are in fact missing a term. So let's go ahead and fill it in. So we'll have 4x cubed, and we're missing that squared term. So plus 0x squared plus 7x plus 4. And now we can go ahead, fill our coefficients in. So we have 4, 0, 7, and 4. We know we're going to bring down this first number no matter what it is. -1 times 4 is -4. We'll add vertically to get -4, multiplying -1 times -4, positive 4, add vertically, we get 11, multiply, we get -11, adding vertically, we get -7. All right, so our remainder is -7, and what we're really concerned about is that this is a negative number. Now what we're going to do is perform synthetic division again, only this time using the 0, and if we get a positive remainder, then that tells us that there is some number between a and b that is a 0 for this function. So let's see what happens. Fortunately, we already know what our function is with the missing term, so we can go ahead and fill in our coefficients here and perform synthetic division again. So we'll bring down that 4, multiply, add, multiply, add, multiply, add. And when we do, we see that we have a positive 4 as our remainder. So we have a negative and a positive, which means that there is some number between a and b that is a 0 for this polynomial. And that's all they wanted us to do. They wanted us to show, to use the intermediate value theorem for polynomials to show that the polynomial function has a real 0 between a and b. All right, so they were telling us already that yes, there is some number between a and b, but we had to show that there was by using synthetic division. In this case, we got a negative and a positive remainder, and that's what we were looking for. All right, there's number 31. Let's take a look at number 32.